Okay, in this video, what I'm going to do is I'm going to talk about how we can divide radicals. This is something that's really, really important, and we're going to rely on a few of our skills from before. I guess before we get too involved with that, I'm going to go ahead and just look at what we can do. As mathematicians, when we see 2 divided by the square root of, well, square root of 4 is already 2, we know that. Square root of 5, let's say. If I have 2 divided by the square root of 5, that is painful as a mathematician. We don't like seeing a square root in the denominator of a fraction. It is not, it's just not something we enjoy. It's like fingers on chalk or fingernails on a chalkboard, pineapple on pizza, other things. It's just not right. So what we like to do is we like to do something called rationalizing the denominator. Basically, we want to turn that denominator into a rational number. As a surd, it's not rational. We don't like that. So it's a fraction. In general, we can multiply fractions by 1 and still get and still have the same fraction. So what we're going to do is we're going to use that trick of multiplying by 1, and I'm going to multiply this by something that's going to get rid of my radical. Well, if I multiply this by the square root of 5, it would just turn into 5, right? Right. But if I do it on the bottom, I also have to do it on the top. So by doing that, I rationalize my denominator, and I end up with 2 square roots of 5 over 5. That is our goal. We want to make it so that there isn't a radical in the denominator. If for some off chance it ends up that all we have is a radical underneath it, it's not a surd, it's something we can, it's the square root of a perfect square, all the better. We're happy with that. But generally it's going to be a surd. So what we can do to simplify that is to just multiply by that. Again, I can show you another example. If I have the square root of 3 divided by the square root of 21. Again, I can't do anything with that. Realistically, I could rewrite it as the square root of 3 over 21 or 1/7. Yeah, that would work. That would be a similar thing. But what I'm going to do is I'm going to rationalize my denominator. I'm going to multiply by the square root of 21 divided by the square root of 21. Again, it's the denominator we care about. Numerator can be as weird or as irrational as anything. So what this would turn into is using our rules. It'd be 3 times 21 on the top divided by 21. 3 times 21 is 63. So this would be the square root of 63 divided by 21. Now, from there, we could actually simplify this. Because the square root of 63 is the same as the square root of 9 times 7. So 3 square roots of 7 over 21, or the square root of 7 over 7. That's fine. We can do that. We don't have a problem with that. I'm good. Okay. That's all great. And what's happening there is when we have a radical. Now, what we really want to be able to do as mathematicians is to be able to take something like 1 over 1 plus the square root of 2 and to rationalize this denominator. And in order to do that, we might just think, okay, I'm going to multiply by 1 plus the square root of 2. But if we do that, we're not going to get rid of our square root. If I did that, I'm going to do it. This is wrong. So wrong. This won't work. If I did 1 plus the square root of 2 over 1 plus the square root of 2, my top would become 1 plus the square root of 2, but my bottom, because that's perfect squares expansion, would turn into 1 plus the square root of 2 plus the square root of 2 plus 2. So this would turn into 1 plus the square root of 2 over 3 plus 2 square roots of 2. I haven't gotten rid of a radical. So what we have to do is we have to use something that we know gets rid of that middle term. Perfect squares. Doesn't do it. I almost got you there. Difference of two squares will. So if I use difference of two squares, if I multiplied that by 1 minus the square root of 2, now the top will still be 1 minus the square root of 2, but the bottom, that's difference of two squares. That's 1 minus 2, because I square 1 is 1. Squaring 2, the square root of 2 is 2. So this would end up being negative 1 minus square root of 2 over 1. I guess let me move that negative back to where it was originally, which then simplifies this to negative 1 plus the square root of 2. And that is my final answer. Using the perfect squares expansion is what your textbook and mathematicians refer to as the conjugate. And the conjugate is what we're going to be using. We are going to use this radical conjugate as our difference of two squares, which will get rid of my radical in the denominator and make everything work. This requires practice. You need to go practice. If you try these problems, if you just work through a few of them, it's going to click, and you're going to say, "Oh, now I see why Stoltz made us do all that factorization and expansion of those rules." Who knew? I kind of had an idea what I was doing. Anyway, good luck. You're dangerous enough to start. Get stuck in. I will talk to you later.